So welcome back, and we're going to take a loop at the south wing now. We're going to focus on for and while loops. Specifically, we're looking for looping constructs. Loops are extremely important in a number of different situations, and as a reverse engineer, someone who's analyzing code in loops, we're not specifically interested, or we don't really care about whether or not it's a for or while or some other type of construct. Really, what we're interested in is identifying that there is some type of looping feature. What might be looping the conditions of entering and exiting that loop sequence, and what that overall net effect is. Like, that's the really important part of all of this stuff, and it ends up showing up in the south wing. So again, this is the Santa's Workshop main lobby. We'll take a look at the south wing now. When we come into the south wing, we'll take a look at the structure, and what we see here is kind of hard to see when we zoom all the way out. But if we zoom in a little bit, we'll end up seeing this control flow that comes down here, branches down to this location, and there's a couple of locations that come all the way back up. Typically in a linear function that's just processing some input without any loops and exiting, you're going to see a very clear, just straight down and exit kind of thing. You won't see a lot of this branching left and right, and certainly you won't see any of these loop back points. So any of these arrows that are actually coming back here are indicative of this loop sequence. And what we're really interested in doing is identifying why we actually get into those loops and how many times we might actually loop through. So let's go ahead and take a look at the actual wing. Let's go to, type that in. You enter the south wing. In the center of this otherwise empty room sits the Lettertron 2000. Beep boop. The Lettertron 2000 is flashing. It begins to speak, now accepting letters. You notice a switch on the side, one setting tickets, the other Christmas keys. You flip the switch. Enter override command. Okay, so perfect. Now we need to do something. If I type in some random value, it just gives me the command again, and again, and again. So I know in order to get out of this, I need to give it a correct command. At this point, the only options I have are either give it the correct command or exit the application, because there appears to be no way to quit or exit other than to give it a correct value. All right, so let's go and see if we can find this override command. Now we know that this particular function is basically the entirety of the south wing. So I don't care about going down again to each one of these different things, and I see a loop here, which may be interesting. In fact, I kind of know just by taking a look at what's happening here. We're taking 0 and putting it into a D word on the stack. We're incrementing this index by 4, and then we're comparing to a certain value and continuing doing that over and over again. So this is essentially a mem set of 0 at a certain size. So we have some type of stack buffer that's been allocated, and we're going to clear everything that's in there. We're going to add 0. We're going to basically blow away whatever the contents are in the stack with a bunch of zeros. And you can see that it's actually happening because of this looping pattern, and just because you see this so often that it just sticks out to me. Plus, I wrote this, so I kind of know from that anyway. As we continue to move down, we see again the system call for CLS, so it's just clearing the screen, and then printing out the beep boop stuff. Then it'll do essentially go into this loop pattern. So this very first loop pattern will come down here and ask us for the override command. And then there's one location where we can actually come up here, and there's another location where it'll say Christmas key mode engaged, and also loop back up here. So essentially what is going to happen here is there's a comparison of this var d. This var d is initially set to 1, and then we're comparing to see if it's 0. So at some point, we want to get var d set so that it'll get us out of this loop. And it looks like whenever Christmas key mode engaged is set, will actually kick us out of this never-ending cycle of enter override command, enter override command. So that's what we're looking to do. The way that we can actually get from this location down into this other location in this basic block is to pass this string comparison. We talked about these tests before, that the test is essentially this comparison against the same value to see whether or not it was 0 or negative or positive, right? So this string comparison, it turns out if we look up the documentation on string compare, if two strings are compared and they're 100% the same, it will return 0. If they are different, what it'll end up doing is returning a value which is the index into the point where they stopped being the same. So if you have like peanut butter and then like peanut jelly or something like that, it'll essentially give you the value right up to the end of peanut, and then that's the value that you get. So if we're looking at a string comparison, really what we want to see, especially if we're looking for a match, is the value of 0. So this is perfect. Right here, what it ends up doing, and we can see this very clearly because Binary Ninja enumerates this for us, is it says enter the override command, who cares what this stuff does, and then I see New England clam chowder. I am a fan of Ace Ventura Pet Detective, and I know at one point he bangs on a door and is asked for the secret command, and he says, well, it's New England clam chowder. He's asked if it's the red or the white, and he can never remember that. So I'm going to go ahead and try that and see if that works. So we're going to do new, and it says Christmas key mode engaged. By the way, it was the New England, the white clam chowder, not the red clam chowder. So now it's in Christmas key mode, and it says give me letters. If we go back to the control flow graph, we've seen that we got this Christmas key mode engaged. It came back up here. It set this var d to 0. It came back here. The comparison matched. So then it says jump if not equal down to here. Since they were equal, it jumps down here and says give me letters. Awesome. This is perfect. This is great. Now, if we think about the conditions that were sort of for this to work, what it was doing is setting up some value and continuing to do this while some value was not equal to something else. So I think that this is a while loop, right? Because there's not some counter that says if you ask the person or the user 300 times for an override command and they aren't able to satisfy that requirement, then go ahead and exit. It's just checking some random value. So until that value actually changes, we're going to continue to do it. That's a while loop. That's just sort of indicative of what's going on here. If we come over to this location, we'll see something slightly different. What it'll say is give me letters. It'll print that out, and then it does an fgets, and then this string span, which we don't have to worry about. It essentially ends up setting the last, the end of that function with a null byte to kind of take care of this character input that gives you like a new line at the end. It's really not important. So it's essentially going to take character inputs and then immediately go into the strlen and then start going down this particular path over and over and over again. All right, so let's zoom a little bit and try to figure out what's going on here. Here is the point that we actually want to start going line by line and trying to understand. We want to break out of this cycle and get through here and hopefully get to this location that says beep boop clank blah 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 is not correct. Actually, we want to get to, I think, this guy. Yeah, here we go. This looks good. And we want to get there. So we want to break out of this particular loop to this location, and we want to make sure that this condition is satisfied so that we come down here. All right. So if we take 7D0 and display it as an unsigned decimal, it's 2000. All right, so this was the Lettertron 2000, and at the end of this loop, it's going to take some value called var14, and it's going to compare it against 2000. All right, this looks good. So if it's not equal, it's going to jump to this location, which we've already seen as this like failure point. It's going to say blah, 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 not correct, and then it's going to exit out. So at this particular point, we want to get here, which means that var14 better be 2000 at the end of this. When we come into this loop, it's asking us for, it's going to perform a string length on this information that was passed in. So we load the effective address here, put it onto the stack, and then call it. So what we can say is essentially this is user input, And by proxy, this is also user input because we're moving that EAX into that location. We don't really care to distinguish between the two. So now if we highlight that down here, we can also see other references to this user input as well. So we get the string length of this. String length will come back in EAX. We store that in EDX. And then we have this concept of var18, which was initialized to 0. And then at the bottom of this one, it's going to be incrementing by 1. So this looks like a counter. And I know it's a counter because we start by 0. We continuously go and do all this stuff. We move it into EAX, and then we compare it against some other value, which is the string length. And then if it ends up being above that particular value, then we'll end up branching one way or the other, right? So this is a counter. This is a for loop. This is for some particular condition between, like, let's say 0 and the string length of the user input, continue to loop over this and then increment by 1, right? So this is very clearly a for loop that loops over the number or the what do you call it? The characters in the user input. This is a little bit inefficient, especially like when you write an if statement and you say that the conditions for, or you write a for loop and the conditions for that for loop are like I is less than string length of something. It's rerunning that string length every single time. Some compilers will probably optimize that out and end up taking the string length and bringing it up here because it's not going to change. It's going to be the same user input. It's going to be essentially static, and then we won't have to actually keep recalling this over and over again. But in this case, if I type in 5,000 characters, it's going to presumably actually do string length 5,000 times, which is kind of ridiculous. So we have this user input. We get the address of that goes into here. We then pass that to string length. The number of string length goes into EDX, and then we start comparing that against the index that we're in so far. That keeps getting incremented down here by this guy in counter. So every single time that this happens, we end up adding this sort of user input reference to AL that gets signed extend. So we're kind of like continuously going through this particular value and adding whatever we're referencing, that particular byte, to var14. So this is some type of like accumulator. So for every single thing inside of the user input, if I type in 10 characters, it's going to go to character at index 0, then 1, then 2, then 3, and it's going to take all of those bytes and it's going to add them to this accumulator and continuously do that over and over again. Once that particular process completes, it's going to say, all right, I've gone the entire length of the user input, and now I've gotten here. That accumulator, whatever has been added that number of times through this loop, better equal 2,000. So one of the things that we'll actually want to do is take a look at what's actually happening in this portion. So when it's doing this fgets, it's getting in a string, and every point in this process, we're going to be going to those strings and adding up stuff, right? So it turns out that the condition that's going to satisfy this requirement is any input ASCII that can be sort of like duplicated a certain number of times to equal 2,000. So for example, if I go to lowercase d, that's a decimal 100. So if I give it 20 d's, at the end of that, d 100 times 20 should be 2,000. So if I come over to here, based on the information that I've got, I should type in 20 d's. It'll go through, EAX will be 100. It'll put it into the accumulator, then 200, 300, 400, 500. And finally, by the time that this exits, it should be 2,000, and it'll kick us down into this location. So let's give it a shot. All right, that is 20 Ds, and I click it, and it says beep, boop, boop, rattle, clank, boom. A key pops out of the machine, you put it in your pocket and rush back to the main lobby. Perfect. So now we're back in the main lobby and we have 2 keys. And we were able to identify this based on sort of like the structure of everything that was going on here. We saw that there were some loops. We saw that there were a couple of functions right before the loops that were getting user input, and then it was looping over things. We looked at the conditions of enter and exit, and we were able to identify a while loop and a for loop, and what the conditions were to actually get to that point. Now, again, all the stuff up here, the inner workings between here, even in here, and all through within here, we just basically didn't care about. We really focused on a few pieces in this basic block and down here, and we focused on a sort of lot of stuff in these two. That carves out about 70% of the rest of this function we didn't really even care about or consider touching. So that speeds up this process quite a bit. If we go and take a look at the code here, which I've conveniently gotten rid of. So we're in the south wing, and we have the Lettertron 2000 begins. So all of this stuff are sort of like failure cases. We come down to this point, it turns out that the code has this ticket mode. And ticket mode is initialized to 1, and then it says while ticket mode is engaged, then we're going to continue asking for this override command. If the override command ends up being this ticket override command, or the override command, which is New England Clam Chowder, then it will set ticket mode to 0, and this while condition will no longer be satisfied and it'll fall out. Then it'll come down and do the string length on user input and continue this process for the amount of strings or characters that we entered. So we did 20 Ds, but you can find some other key that works too. As long as the number of characters that you add in, all of those ASCII values add up to 2000, it'll actually work, right? So 20 Ds is just the easiest one that sort of comes to mind. And that's it. After that point, it'll produce key or it'll fail. The produce key ends up doing checking to see whether or not our keychain, which is a globally defined structure, ends up having the second key. If it does, it just says you two seem to have met before. Otherwise, it actually sets that particular structure and you're good to go. So that's the kind of pattern that we ended up seeing, is these particular loops that come back could be any number of situations that cause that, but when we really start to kind of analyze what the conditions are for entering and exiting, we can discern whether or not that was a for or while loop. Hopefully that was helpful to you. In the next one, we'll take a look at the next wing and continue on from there. See you then.